Welcome to another video. Today I'm going to solve an exercise related to what we call conical pendulum. So let me read the exercise. In the conical pendulum, the constant angular velocity has a value of 4 radians per second. The length of the pendulum is 1.16 meters. First, determine the magnitude of the tension force in the string and the angle it makes with the vertical for a ball with a mass of 12 grams. So I try to draw the conical pendulum here, and then I represented the forces. In the string we have the tension force, and of course it's a ball and it has a mass, so of course we have weight, it's weight. So then is centrifugal force. Why? Because as you see, this ball will be describing a circular trajectory. So of course, we need to have what we call centrifugal force. Okay, great. From now on, I don't know whether it's geometry or not. Suppose we have this, and this. See, now we succeed to build a parallelogram. And of course I can say this is alpha. As you see, this side and this side are both parallels, and here I can say that of course it's 90 degrees. And here of course I can say what it here, let me write here, I can say is 90 minus what, alpha, because if you sum this angle, this angle, this angle, you'll get is 180. That's why I said that. Okay, let's determine the magnitude of the tension force. Okay, first I will use an easier way so that you can understand. What I have here, I can take cosine of this angle, 90 minus alpha. Cosine of 90 minus alpha. So let's do this. So it's equal to what? This force, centrifugal force, over, because it's a triangle here, we have a triangle, so over the tension force here. This is equal, cosine of this is equal to sine alpha, and you could have done using this angle too, you'll get the same thing. Okay, so here first you need to know what the centrifugal force is equal to this, mass times velocity, linear velocity square, here it's mass, over rate. But we know that linear velocity is equal to rate times angular velocity. So if you plug in this here, you'll get what? Mass times rate times angular velocity square. So what I'm going to do, I'm going to plug in that here. Then good. Yeah, then okay. Ray, they are talking about this distance, and then I'm going to use trigonometry here. Ray, I can say first sine, it's sine of alpha, it's equal to what? This ray over this length here, which is L. Good. So I can say ray is equal to, yeah, it's sine. Oh my God, sine. Because I speak Portuguese, Portuguese is my native language, so sometimes I tend to put that like that in Portuguese. Okay, sine of alpha times, yeah, it's L, right? So this ray is equal to this, so I can come here and just put this sine. Good. So we get this. We can cancel out this and this. So tension force is equal to mass times length times this. Okay. Remember, we have what? Mass, we have length, and we have the angular velocity. Yeah, mass is this mass. It's this grams. We need to change to kilograms. So we get what? This, right? We get this. So it's 12 and left. Yep, we get this. And angular velocity is 4, and 4 square we all know that is what 16. Yeah, it's 16. Here it will give us a result. Yeah, it's like this. It will give us this newtons. Good. So we already have the tension force. From now on, what I'm going to do next? Let's do our sheets again. I said that this is a parallelogram, and the resultant force here, resultant vector, I mean. Yeah, but I can say resultant force. As a parallelogram, one of the properties of parallelogram is that we can do this. This angle is equal to this angle. See? Good. What next we can use? Yeah, I can say cosine is cosine of alpha. If you come here, you have this cosine of alpha. We have a triangle here. Again, you have a triangle. Is equal to what? Weight over. But here we don't have it, right? We have, man. We have. Check this vector. Tension force here. If you see, take this vector and plug in. Check and put here. Then you will have a triangle. So I can say that is weight over tension force, and weight, of course, it's mass times this gravity acceleration, over the tension force, and of course mass here it's equal to this. I'm considering gravity acceleration equal to 10. And then you got this. But yeah, it's this, right? Yeah, and this. Yeah, we can cancel this and this. So we get cosine of alpha, it's equal to what? Yeah, I'll put like this. Put like this. Good. Now I want alpha, not cosine of alpha. Don't worry, my baby. Don't worry. Don't worry. You can take its inverse, So I can say that arc cosine of this. Yeah, it's equal to what? Just put in your calculator and then you'll get approximately equal to, yeah, 57 degrees. So that is the bottom line here. You start playing here with these angles, So guys, let's call it a day. See you on another video.